Welcome back. In this video, we will be discussing the conversion between units and dimensional analysis. During a previous video, we discussed how we can create various unit conversion factors knowing the prefixes of SI units. But there are some equalities that are common that we use in science. While most countries use the SI units natively, most people have a tough time converting from the imperial units to the SI standards. How many centimeters are in an inch? How many meters are in a mile? How many gallons are in a liter? These questions can be answered using unit conversion factors. A unit conversion factor is an equality showing the same measurement expressed in two different units. The best place to start is with one that you know. 12 inches is equal to 1 foot. We can write it in two different forms. We have our inches and we have our foot. But now we can write the equality the other way. This will allow us to convert from one unit to another. As seen in the previous video, the format to accomplish this conversion is done by putting the unit that we are going to on the top and the unit we would like to eliminate on the bottom. So if I want to go from 15 feet to inches, we can use our unit conversion factors. We have feet. We want to go to inches, so feet must be on the bottom. Feet and feet will cancel, leaving us with inches and producing an answer of 180 inches. It's important to note that we had two significant figures in our feet to start off with, so our answer must have two sig figs as well. Using the same format, we can take the equalities of centimeters to inches as well as liters to gallons. We have 2.54 centimeters per 1 inch. And we also have 3.785 liters in 1 gallon. And building unit conversion factors are going to help us leading to our science. We can take both of these going from our metric units to our imperial units. Notice if I cross multiply, I will get a factor of 1. Now that we know how to build our conversion factors, we need to learn how to use them. We will often make long strings of conversions in order to get the units that we want. Most beginning science students forget units and don't know why they are important. But as we're about to show you, they are a safety net for us to make sure that we don't make mistakes. Let's try a multi-step conversion. How many kilometers are there in 4,550 feet? Now that we have feet, we must find a string in order for us to accomplish our kilometers. We cannot go directly from feet to kilometers, so let's use some of the factors that we know. we can go from feet to inches. We've seen this conversion before, as you have seen over here. So now we can say that 1 foot is equal to 12 inches. Now that we have inches, we can make that jump using this conversion factor and go from our imperial units to our SI units. Now we have our centimeters. It's important for us to now go to our base unit, which is the meter. Using our previous video, 10 to the minus 2 meters is 1 centimeter. We're to meters, which is good as our base unit, but it's not the unit that we wanted originally. So now we need to go to the kilometer. 1 kilometer was equal to 10 to the third meters. As you can see, I have 4 different unit conversions. And as you're working through this process of writing down many factors, remember that the sayings we always use: know where you're coming from and know where you're going. Or we can say the old unit on bottom and the new unit on top. As you can see, we are going to be able to cancel out each unit as we go, and we're going to be able to produce the answer that we want. Our feet will cancel. Our inches will cancel. And finally, our centimeters as well as our meters. We get the unit of our kilometers, which was our target, providing us with an answer of 1.39 kilometers. I highly recommend that you do not put in any number into your calculator until you have done this unit cancellation on paper. This prevents you from using the wrong unit, flipping a conversion factor so that the units don't cancel, or performing the conversions that don't really reach your desired target unit. Once you confirm that all of your units will cancel, then use your calculator to perform the math. A nice tip is that all the numbers on the top of the fractions can be multiplied together while we divide by all the numbers on the bottom of the fraction. As you progress through chemistry course, your professor will let you know which unit factors are considered required knowledge and which ones that you will need to learn and have memorized. Other ones you will see that we will give you during various examples. Let's try one of these examples with more unit conversions, and you can see how that'll work. Then we will show you how to do a unit conversion using an exponent in your unit. How many fluid ounces are in 1 liter? We know that first conversion factor because we showed it to you earlier. So now we need to find the others. Because we weren't asked to learn these conversions, I have to provide them with you. 1 gallon is 16 cups, and 8 fluid ounces is 1 cup. Please note that these are exact definitions, not measured conversion factors like the liters to gallons. Exact definitions will not be used in determining the number of significant figures. So let's start with our 1 liter. We have our 1 liter, and let's go from liters to gallons. As we remembered from our unit conversion here moments ago, gallons and liters, that 1 gallon is 3.785 liters. Now, a moment ago, I described to you, in this case, that 16 cups is going to be equal to our 1 gallon. We've gotten to cups, but we're still 1 step short. We must now go to our 8 fluid ounces in our 1 cup. As you can see, we are going to be able to cancel out the various units. If I put this into our calculator, you will get an answer of 33.8 fluid ounces. Now let's go and check our units just to double check. Our liters and liters will cancel. Our gallons and gallons will cancel. Cups and cups will cancel, leaving us with the fluid ounces that we want. Our original value of 1.00 liters had 3 sig figs. And because all of our conversion factors were multiplication and division, our answer is going to have 3 sig figs, which gives us a good answer of 33.8 fluid ounces. Let's finish with one last example. The space shuttle has a maximum acceleration of 100 kilometers per minute squared. What is this value in meters per second squared, which is the standard SI unit of acceleration? Well, we know that there are 10 to the third meters in 1 kilometer and that there are 60 seconds in 1 minute. So let's start with our original value of 100 kilometers per minute squared. This is a really nice value, but this squared is a new and more difficult adventure that we have to deal with. The best way of looking at this is this can be explained as minute times minute. We need to convert to a unit that is located on the bottom, but this is different than what we've seen before. In order for us to cancel it out properly, we must have our new desired unit on the bottom as well, meaning that the old unit now has to be on the top. This is done by having our minutes on the top and our desired unit of seconds on the bottom. Using our conversion factor, we know that there is 1 minute with every 60 seconds. Notice that the minute is in the numerator, our seconds are in the denominator. However, the unit is not just minutes, it's minutes squared. What we do to this unit, we must do to the number as well, and we are going to square it. We are going to take our entire unit conversion factor and square it. This is going to give us the quantity of 1 minute squared in the numerator and the quantity of 60 seconds squared. But it's not just 60 anymore. We must square that number, so our denominator will actually be 3,600 seconds squared. We are now able to cancel out our minutes squared in our denominator and our numerator of our conversion factor, leaving us with our seconds squared. Once we've accomplished the time, we must get the units of meters into our equation. So now our second conversion factor is going to say that 10 to the third meters is 1 kilometer. We can go back to our original term and notice that our kilometers and our kilometers are going to cancel. And the units that we are going to get at the end are going to be our meters from our new unit conversion and our seconds squared. So we have the desired units that we want. In this case, as we showed you in the last example, multiply by all the numbers on the top, divide by all the numbers on the bottom, remembering that this 60 is really 3,600 when we square it, and you will get an answer of 27.8 meters per second squared. As you have seen in this video, that unit conversion and dimensional analysis will become a very useful tool for you in your problem-solving arsenal. In general chemistry, you will use it all the time to convert from mass to moles, moles to atoms, and to handle concentrations. Having these fundamentals will allow you to tackle any given problem in our course.